According to Professor Z, one of the deepest mysteries in physics is that the dynamical evolution of quantum world is given by an exponential of the Hamiltonian, and the Boltzmann factor in physics also given by the exponential of the Hamiltonian. So there is a connection between imaginary time and inverse temperature. The question is whether this is just coincidence or deeper. The answer can be given by a hidden structure in the vacuum, a network of springs, which is a key in the integration of quantum field theory and gravity. Each spring has a variable length L and fixed angular momentum h bar. Springs can be connected to form a network. A blue arrow is drawn to show that waves propagate along the spring. Here the time variable is defined as tau. A red arrow is drawn to show the oscillation of the spring node. Here another time variable is defined as an imaginary time t. In the vacuum spring, there are relationships between energy, time, and temperature, which were extracted from Planck unit expressions. The green box shows the inverse relation between time and temperature. As you continue analytically to the imaginary time, you will get the temperature. Professor Z's question leads us to a very important next question. Can vacuum springs be incorporated into the existing successful field theories? The answer is yes. However, we need a little change, a new interpretation for quantum field theory and gravity. It's called the vacuum spring interpretation. A network of springs is a hidden structure for fields in the vacuum. Here, the particles cause the excitation of fields, or springs, and fields create the motion of particles via springs. Vacuum spring interpretation is developed as an alternative to wave-particle duality. The interpretation is deterministic and local. It integrates quantum field theory and gravity via a network of harmonic oscillators. Postulation is simple. QFT and gravity can be built with springs extracted from Planck units. Each spring has a variable length L, the constant angular momentum h bar. L is the product of c and t, where t is the time to travel the spring at the speed of the light. The equation shows how the time dilation and the length contraction are related. The product of energy and time is h bar, and the product of momentum and length is h bar, following the uncertainty principle. The spring equation can be expressed as a function of fields. Gamma is for the scale of the spring. Gamma 1 is for Lorentz transformation. Gamma 2 is for gravitational field. Gamma 0 is for the zero-point field. Gamma E is for the electromagnetic field, and dots are for the rest of the fields. Spring is a building block of quantum field theory. A network of springs is like a lattice of point masses connected to each other, where Lagrangian is defined at each node. If we take the continuum limit, we get quantum field theory. QFT and string theory are founded on this harmonic paradigm. Spring is also a building block of gravity, where the gravity is encoded into spring length L. The number of springs W represents fixed spacetime background, which quantum field theory is based on. The spring length L represents dynamic spacetime background, which gravity is based on. The yellow circle shows an area where spring length L varies dynamically, while the number of springs W is fixed. On a larger scale, a network of springs can be described as the Einstein field equation. On a quantum scale, the Einstein field equation can be described as a network of springs. There are direct relations between terms in Einstein field equation and terms in spring equation. G mu nu corresponds to gamma 2, and lambda times G mu nu corresponds to gamma 0, and T mu nu corresponds to E, energy. EM field and other terms do not have counterparts in Einstein field equation because their effects are negligible on a very large scale. Lorentz invariance means that the laws of physics are the same for different observers. The speed of light is constant at each spring, regardless of how springs are transformed. Gamma 1 is defined by Lorentz transformation, and gamma 2 is defined by Schwarzschild metric. Gamma 0 is obtained from the measurement of the vacuum energy, and other gammas are defined by Lagrangian and the equation of motion. This interpretation belongs to the third paradigm shift in spacetime. The first is the special relativity. The second is the general relativity. And the third is the vacuum spring interpretation. It is also called as the spacetime rule, which describes how the spacetime background can be built from springs. Two kinds of lengths play the key role in integrating GR and QFT. The number of springs W represents the fixed spacetime background, which QFT is based on. The spring length L represents a dynamic spacetime background, which gravity is based on. Spring equation is a function of gravity and quantum fields. Spring interpretation and string theory are based on QFT. Thus, we can ask whether it is possible to incorporate spring into string theory. There are similarities between them. First, 11 dimensions of spring theory can be explained in terms of 11 degrees of freedom of springs, which will be discussed later. Second, applications such as black hole radiation, Unruh effect, quark gluon plasma viscosity can be derived based on spacetime rule. There are advantages in incorporating spring into string theory. Spring interpretation provides experimental evidences at low energy, such as studying multi-electron systems and predicting ionization energy and bond energy. It could also show that the integration of gravitational lensing and reflection is possible by the spacetime rule. The uncertainty principle embedded in the spring holds from low energy to Planck scale energy. Spring could be a great tool to provide experimental evidences for string theory in the future. Spacetime rule could be helpful in finding solutions or explanations for difficult problems in physics, such as the hierarchy problem, cosmological constant problem, dark energy and dark matter, double-slit experiment, quantum entanglement, graviton and gravitational wave. All will be discussed later. Feynman's path integral can be mapped to spring network. As time evolves, propagators may move along the springs, and events occur at the spring nodes. However, unlike wave-particle duality, a path along the springs is deterministic. For instance, a dynamic change of the spring network, marked as the yellow circle, would change the path from x0 to xt. Choosing a path depends on the initial conditions of the spring network. In order to understand the process, let's do thought experiments with hidden Galileo ramps in the vacuum. If we do not know how the ramp changes dynamically, the probability can be used to predict the outcome. Here the object follows one path along the ramp and does not go through all the paths at the same time. At quantum scale, a hidden Galileo ramp consists of springs and waves are propagated through them. The path given the initial conditions is deterministic and depends on the probability of the initial conditions of the ramp. Unlike pilot wave theory, the communication is local. Lagrangian has interaction terms with neighboring springs, where the communication speed is limited by the speed of light. Thus, spring interpretation is the only local and deterministic interpretation, which supports both QFT and gravity. Spring interpretation has important experimental evidences. The ionization energy can be obtained by extending Bohr's model to multi-electrons. Inside the green box, the angular momentum L is given as a product of radius r and momentum p. The ionization energy E is defined as the sum of the kinetic and the potential energies, where zeta 1 reflects the charge shielding effects on the potential energy by other electrons. By using spacetime rule, zeta 1 can be represented as a function of W in fixed background. The centripetal force of the valence electron is said to be equal to the Coulomb force, where zeta 2 reflects the charge shielding effects on the Coulomb repulsion by other electrons. By using spacetime rule, zeta 2 can be represented as a function of W in fixed background. Finally, ionization energy equation can be obtained as a function of zeta 1 and zeta 2. Experimental results show 89% to 100% accuracy for most cases. By improving the force model, the accuracy could be increased even further. For bond energy, dozens of molecules were tested. Especially for benzoic acid, more than 6,000 interactions between particles were simulated using the spacetime rule to get results. Currently, the state-of-the-art simulation tool is based on the density functional theory. The potential energy is a function of distance r and depends on the gradient of the density. Spring interpretation takes a shortcut to get the same result. Instead of using generalized gradient approximation, charge shielding variables zeta 1 and zeta 2 obtained only using W in fixed background. For instance, distance between electrons is 5. Distance between an electron and the nucleus is 4. If gravitational lensing and refraction could be present at the same time, it would have been a strong evidence of gravity and QFT integration. However, since gravity is so weak, it is very hard to do such an experiment. In cosmic scale, gravitational field changes gamma 2. Gamma sun over gamma 0 shows the relative speed of light at different places as drawn in red and blue arrows. In quantum scale, electromagnetic field changes gamma 2. Gamma water over gamma air shows the relative speed of light between mediums. Here, the principle of least action can be interpreted as the least number of h-bars or the least number of springs. String theory and spring interpretation have the following common applications. The first is Unruh effect, that an accelerating observer will observe blackbody radiation. The second is Hawking radiation, which is the power emitted by the black hole. The third is quark-gluon plasma viscosity, that the lower bound of QGP shear viscosity is proportional to entropy density. 11 dimensions of string theory in reality can be explained by 11 degrees of freedom of each spring. In the green box, energy, length, momentum have 3 xyz components, where each one corresponds to acceleration, position, velocity in 3-dimensional space. As time evolves, acceleration changes velocity, velocity changes position, and position changes energy, length, momentum again, which creates a perpetual oscillating motion of springs over time. Einstein's field equation also has 11 degrees of freedom, 10 from energy momentum tensor T mu nu, and 1 from gamma times G mu nu. In ADS-CFT correspondence, the geometry of spacetime is described in terms of a certain vacuum solution of Einstein's equation called anti-de Sitter space. The image shows a tessellation of a disk by triangles and squares. Since string theory and spring interpretation have a few common applications, there is a strong possibility that each edge could be described by the spring equation. Cosmological constant problem is the disagreement between the observed values of vacuum energy density and theoretical large value of zero-point energy suggested by QFT. Discrepancy can be as high as 120 orders of magnitude. In space-time rule, it's not a problem. Uncertainty principle is embedded in the spring energy density. It ranges from an observed dark energy to the Planck particle density, which is 10 to the 129 times larger. In space-time rule, hierarchy problem is not a problem. When various fields are sharing a same spring, hierarchy among fields are recommended to differentiate signals. It's similar to assigning a different frequency band for each radio station. In order to achieve high energy efficiency of the universe, the gravity should be weak as much as possible due to its omnipresence. Vacuum spring energy is needed all over the universe. The only candidate for such enormous amount of energy is dark energy. At the fluctuation of the vacuum, short-lived virtual particle-antiparticle pair is required. During the process, the energy can overflow or underflow. In order to handle spring energy limit, Planck energy buffers are needed in the form of dark matter. The graviton is the hypothetical quantum of gravity that mediates the gravitational force. In order for the spring networks to work, graviton is needed at every spring node. Gravitational waves are disturbances in the curvature of spacetime, generated by accelerated masses that propagate as waves outward from their source at the speed of light. Gamma 2, or Planck length over L, represents the curvature of spacetime at the spring level as shown in the figures. The Planck length and the physics inside the nucleus will be discussed in the next video. It's based on T-duality, where the length term is reversed in the spring equation. The listed research topics are strongly related to the spacetime rule also. Thanks for watching. If you are interested in doing research related to vacuum spring, you are welcome to send me an email and ask any questions.